Hi students, welcome to Vedantu J English. I am Diksha Ma'am, your chemistry master teacher. And students, let me know in the chat box if I am clearly visible and audible to all of you or not. Hello, yes, everybody. Am I visible? Am I audible to all of you? Yes, students? Okay, perfect. Chalo. Now, let us start this session, and this is going to be a small session only because a very small and very interesting topic, simple topic we are going to learn today, that is empirical mass and empirical formula, right? But before that, I want to know how many of you have done your homework, right? And we can see over here, Abhijit has done his homework, Ramu, then Kavita, then Sai. Sai has not done the homework. She's asking about, ma'am, when you will start organic. Don't worry, beta. After completing this basics of your like physical chemistry, right? Then structure of atom, then periodicity, I'll start with GOC as well, right? So there is a sequence that I want to follow, right? Then yes, Sulo has answered it. Very good, very good, very good. So awesome. Right, ma'am, very blessed. Your foundation clear with this channel. Ma'am, very interesting. Thank you so much. Most welcome, most welcome. So these comments are what makes my day, right? So it's good if when you comment, for you, it maybe it's just a comment, but for us, it's the appreciation, it's the feedback that we genuinely need from you so that we can improve. If you want that, if you think that something is, it's not only about the positive feedback, you can also criticize us that, ma'am, can you please do this, that will be more beneficial for me, right? So I would love to see your feedbacks in the comment section. Okay, yes everyone, let's start and let us see what was the homework. The homework was how many moles of H2 are needed to react completely with 2 moles of N2. See, what you have here is N2, 3H2 and this. Now, how many moles of H2 are needed to completely react with N2? See, is this a question of limiting reagent? No. In the limiting reagent, what I told you, in the limiting reagent, they will give you every, like, how to calculate the moles. That means they will give you either hint or directly they will give you the moles of every single reactant, right? So this is not a question of limiting reagent, but this is a question of stoichiometry, right? So can I say now that this is 1 mole, this is 3, this is 2 mole. I need to find, they have given me 2 moles of this. So they are saying that we can just say that 1 mole of N2 gives 3 mole of H2, reacts with 3 moles of H2. Then 2 mole of N2 will react with 3 into 2, that is 6 mole of H2. So answer is going to be 6 is the correct answer here, right? Okay. I want all of you to do the homework. The reason being, I have already prepared this DPP for each session, right? Each chapter I have prepared DPP, right? But for that, I also want that you guys comment down so that in the end, when we complete this chapter, I'll give you the DPP of that chapter, right? You will be also happy that, okay, now we have our DPP, now we can practice, right? But for that, in every single chapter, the amount of sessions that we'll have, I'll see that how many of you are actually doing the homework, right? If you're genuinely sincere that I will help you, right? We will solve DPPs, right? Don't worry about that, right? Okay, yes. Now, let's see this empirical mass and formula, right? Let's understand. The topic is empirical mass and formula. Let's understand what is empirical mass. See, if you talk about any formula, let's talk about the formula of C6H12O6 glucose, right? Now, this is the molecular formula. This is the molecular formula, right? Now, if I say that you just have to divide it by any number to make it into a simplest whole number ratio, right? So I'll divide it by 6 and this will become equals to CH2O, isn't it? This will become equal to CH2O. Now if you see, This is your empirical formula. This is your empirical formula. That means the simplest whole number ratio of a molecular formula is nothing but a empirical formula, right? Okay. The empirical formula of a compound may be described as formula that gives the simplest whole number ratio of atoms of various elements present in molecule of the compound, right? Now, you can assume that, ma'am, if I have given you molecular formula, then you can easily calculate the empirical formula from there, right? If I have given you molecular formula, then what you can do, you just multiply it with the number, no, you just divide it with the number, some number I am taking at n, you will get the empirical formula, right? Now, that number will be defined. If you look at this molecular formula, you can easily see this will be divided by 6, only then I'll get my empirical formula, right? That means by division of this number, you will get your empirical formula. And if you have to go from empirical to molecular formula, you will have to multiply this with that number n. Okay, you have to multiply with that number n. Now, one more thing to understand here, that we are saying that, let me know firstly if this is clear to all of you or not, right? I am saying that this is the molecular formula, right? Whenever I have to go from molecular to empirical formula, I will divide it with some number, right? So that I can make a empirical formula, which is a simple whole number ratio, right? But if I have to go from empirical to molecular formula, I have to multiply with that number, right? Now see one thing. If I give you just a formula, right? Let's say I have given you just a formula. I assume that the formula is CH3CHO. Okay, this will be C2H4O. Now, or I would say COH. Okay, so CH3, let's see acetic acid. You have CH3COH, that is your acetic acid, right? Now, this is nothing but C2H4O2. Now, if I give you only the molecular formula, will you be able to calculate empirical formula? Easily. How? This is, ma'am, C1, this is H2, this is O1, right? Now, can you see one thing? This is also CH2O, this is also CH2O. That means if we are, two things from here we can say. That means if we are given if we are given one empirical formula, right? If I just give you that this is your empirical formula, this I don't give you, right? Calculate the molecular formula. If I ask you calculate the molecular formula, will you be able to calculate? You don't know what number to multiply it with, right? So you should know the number it should be multiplied, right? One thing, right? So that means if we want to calculate molecular formula to empirical formula, that was quite easy. I had this molecular formula, I divided it by 2 and got my number. That is empirical formula, right? But if nothing is given to you, they have just given you the empirical formula. Now they ask that calculate the molecular formula. You have no idea about which number to multiply it with. Because with this empirical formula, you can also have C2H12O6, right? You can also have CH3COH. You can also have other so many formulas which will have the same empirical formula, right? That means one molecular formula is for only one compound, right? Okay, it can differ in isomerism, right? That means isomerism is same molecular formula but different structural arrangement. That can happen, but still one molecular formula will define only the same number of carbon, hydrogen and oxygen. That is fixed, right? If I say this is the molecular formula, carbon, hydrogen, oxygen is fixed. That means I can say this is glucose. If I say this is the molecular formula and I arrange it like this, I can say that this is acetic acid. But if they give me this CH2O, then CH2, if it is multiplied by 2, it will be C2H4O2. Multiplied by 3, it will be C3H6O3. Right? Multiple formulas. Just give me a second. Oh God, I'm so sorry. Okay. Multiple formulas you can generate from here. Right? So that means we are not just happy that, okay, we have empirical formula. See, in the exam, they will ask you to calculate the molecular formula, right? And they will give you the hint regarding empirical formula, right? And molecular mass. And from that, you have to calculate, right? So now I will define that how to calculate. But before that, let's take this one more example. If you see that molecular formula of any compound is N2O4, then the simplified ratio will be NO2. That is the empirical formula. Now, it's not like this is, see, it's the same thing. If you talk about CH2O, this is also HCHO. That means methanol is also same formula, right? This is also empirical formula of glucose, empirical formula of acetic acid, but this is also methanol. It can also be transformed into methanol, rearranged into methanol. So that means, right, we can't say empirical formula is this and let's calculate molecular formula. No, right? So you have to have a proper distinction of that thing, and let's understand that thing, right? Okay, let's understand that thing, right? Okay, yes, everyone, let's understand that thing. Now I'll define something here, right? I'll give you a flow chart, right? Firstly, I'll give you two formulas here, right? Then we will learn the flow chart, okay? Two formulas are very important. Two formulas are, these two formulas are, I'll just write it here. First formula is, as we have discussed, molecular formula is equals to empirical formula N, right? That means if I was saying that here N is equals to 2, right? So molecular formula will be NO2. Here it will be 2, so it will become N2O4, right? Similarly here, it was CH2. So if I apply here CH2O and here multiplication factor is 6, so answer will be C6H12O6. Here it will be, this is CH2O, this is multiplication factor is 2, right? Now this is C2H4O, O2. I know the next question in your mind is, ma'am, what is this N? Right? The next question is, ma'am, what is this N, ma'am? Let's understand what is this N, how to calculate this N, right? Okay. So one formula is this and the other formula is molecular mass is equals to N into empirical mass. Okay. Don't worry, right now just look at the formula that I am giving you, right? Now, what we will do, right? What will be given in most of the cases, what will be given in the question, right? What will be given in the question? See, if they are asking you the molecular formula, what they will give you? They will give you percentages of atoms, right? This will be given. Always you will see all the question, this is standard kind of question. This is given, right? Percentages of atom is given. They will give you then molecular mass. Molecular mass. This they will give. Percentages of atoms is given, molecular mass is given, right? Now they will ask you calculate the empirical formula, calculate the molecular formula by just these two things, right? So how do you calculate? Okay, what you will do, firstly you will make a table. You will make a table. In that table, what you will do? In that table, what you will do? You will make a section in which you will write the atoms that is present here, right? Then in another section, you will write the percentages of the atoms of each atom. Percentage will be given to you. In the third section, you will write the molar mass of one atom. Molar mass of 1 mole of atom, right? Then this is given. Then you will calculate moles and their simple whole number ratio. The simple is what I will write here directly, right? What will be given? Here they will give you atoms that is present. Always I will do this thing. Oh. Ma'am, you always do this thing. I don't know why. I don't know why. I don't know why. Okay. So let's see here, atoms you will write. Then in this case, you will write the percentage. Here you will write the molar mass. Now understand one thing, right? Either the percentage will be given to you or ratio will be given to you, right? Okay. Let's imagine they have given you 70% of carbon, 30% of hydrogen, right? That is in the organic formula, organic compound, right? Now 70% means 70 gram of carbon. This means 30 gram. That means this percentage is telling you nothing but the given mass here, right? Okay, understood? So that is nothing but the given mass. And tell me how to calculate number of moles. How to calculate moles? Moles is nothing but given mass by molar mass, right? Percentage is given and that is nothing but that is grams only. Don't worry, when I will solve the question, you will get the more clarity on this as we solve the questions, okay? And the last, we will calculate the simple whole number ratio, okay? In the end, we will calculate simple whole number ratio. That will be 1, 2, 3, 1, 1, 1. Anything like that will come up while solving the question, right? Now, see one thing. I also told you that they can also give you the ratio. In ratio, they can give you carbon ratio, hydrogen is 7:3. Right? Okay. Then what you have to take is, you can't just take 7 grams here. Right? You can't just take 7 grams. Right? This 7:3 means nothing but if I take 1, if I take, let's say I'm talking about that this will be, if I have to convert this into 100 percentage, right? So if this is 7:3, if I multiply it with 0, it will become automatically 100, right? Okay, so that's how I'm going to write it here, right? So that you should be clear on. If your ratio is given to you, you have to convert it into that set where out of 100 you are telling the percentages here. Always remember, this is how we are calculating. And if they directly give you the given mass, then there is no problem in that, right? Okay. Now the simplest whole number ratio will be nothing but empirical formula. From here you will calculate the empirical formula, right? Now if you have empirical formula, you know that empirical mass you can calculate. See, if empirical formula is CH2O, you can calculate the empirical mass. If you know the empirical mass here, then we can apply this formula. Molar mass is equals to N into empirical mass. And in the question, molar mass, this should be molar mass, right? Molar mass will be given to you. Molar mass will be given to you, right? If molecular mass is given to you, convert this into molar mass by replacing U with G, right? That I have told you already in mole concept, right? So now N will be equals to nothing but, you will have to calculate the value of N here, that is nothing but molar mass by empirical mass. Then put the value of N here, that is molecular formula is equals to empirical formula N. This is going to be the sequence how we are going to solve every single question of empirical formula. Now let's take an example and solve one of the question, right? Okay, this is what I told you about the formulas. Molecular formula is equals to N into empirical formula. N is equals to molar mass by empirical mass, right? So if example is benzene is given, molecular formula is this, molar mass is 78. Empirical formula is divided by 6. So N is going to be 6 here, right? Empirical formula is CH. So empirical mass will be 12 plus 1, that is nothing but 30. Okay, that is about all the terms here. Now let's calculate the question so that we can understand what is happening here, right? Find the simplest formula of a compound with percentage of composition carbon and hydrogen is given to you. See, simple is, firstly what I told you, you have to make a table. Okay, you will make a table here, right? Table is small, table is big, doesn't matter, you have to make a table. This will be carbon, hydrogen, this will be percentage, this will be your molar mass, this you can say is your atoms. Okay. Now, if I say, I'll just write it down directly, this is carbon and this is hydrogen. Carbon, it is 80%, so I'll write it 80. This is 20%, I'll write it 20. Right, overall it is 100, so good. Right, now the atomic mass will be 12 here, here atomic mass will be 1. Now you have to calculate the moles. That is this divided by this, that is percentage divided by atomic mass, 20 percentage divided by atomic mass. Okay, if you want me to write it again, I can write it again as well, that this is the atom, this is percentage, this is atomic mass, this is moles, and this is ratio, right? Now, when you solve this 80 by 12, you don't have to solve this in points always, right? So 80 by 12, 26240232 20 by 3. It is nothing but it is coming out to be 20 by 3. This is 20 by 1. So if I want to calculate the simplest whole number ratio, if I multiply this with, this is 20 by 3, this is 20 by 1, I multiply this with 3, I multiply this with 3, right? Now this will become 20, this will become 60. Now when you calculate the ratio here, 0, 0 will cancel, this is 2, this is 3, so it will be 1 ratio 3, right? So can I say the empirical formula is going to be C1H3, right? What I did by applying maths, I just solved this question this way, right? Okay, once you have this question, then can you say this is nothing but the empirical formula? Now they are asking you, they are saying that the molecular mass is given to be 30, right? So empirical mass, you can say N is equals to molar mass, molecular mass 30 divided by empirical mass. So empirical mass is going to be 12 plus 3, that is 12, 13, 14, 15. So it will be 15 here, so it will be 2. So we can say molecular formula is equals to empirical formula, that is CH3. Here it will be 2, so it will be C2H6 is the correct answer here, right? That's how you can calculate the empirical mass, empirical formula in a very, very simple way. This is one of the simple topics of some basic concepts of chemistry. Okay, right, everybody? Next is they are saying that find the empirical formula, right? Now you have to find the empirical formula of a compound that contains which thing? That contains 26.6% of potassium. Now students, we will again make this table, right? Again we will make this table, right? Same thing we are going to do everywhere, right? Here the atoms we will write, here we will write the percentage, atomic masses, then the ratio, then the simple whole number ratio, right? You can write it here, right? Atoms, percentage, atomic mass, moles, or you can also write percentage divided by mass, right? Molar mass, or you can say atomic mass, right? And this is your simple ratio. Simple ratio. Okay, let's solve this. Okay, guys, shall we solve? Yes. So what is given to us? They have given the empirical formula contains this much of potassium. Potassium is given to you, right? Chromium is given to you. Oxygen is given to you, right? See, by this only we have an idea what is the compound that is going to be, but still we have to solve it, right? So potassium percentage is given to be 26.6 percentage, right? Molar or atomic mass is 39, right? Chromium it is 52, molar atomic mass is given to be 52, and percentage is 35.4. 35.4. For oxygen, it is 38.1, right? And then this is nothing but 16. Students, sometimes now what they do in the exam, they will give you chromium is 35.4, potassium is 26.6. It also has oxygen, but they will not give you the percentage of oxygen. Then what you will do? Add these two things, subtract it from 100, you will get the percentage of oxygen, because the addition of all these percentage has to be 100. Okay, so if they have not mentioned any atom, they have mentioned that atom, but they are saying they have not given the percentage. So you can answer it by taking total percentage as 100, right? Now this is 26, yes, 26.6 divided by 39. This is 52 divided by 35.4. This is 38.1 divided by 60, right? Okay, so this is what you have here. The best way to calculate this is, right, you have to calculate the simple whole number ratio here, right? Okay, so let's calculate the simple whole number ratio. Just wait a minute. Just give me a minute. Let you also calculate. I'll also calculate this. Okay, 35.4. 1.46, that is 26.6 divided by 39, that is 0.68, and this is 38.1 divided by 16, that is coming out to be 2.3. Okay, so if I divide 1.46, wait a minute, 0.68, yes. Okay. Okay. I think the formula is somewhat coming out to be, just give me a minute. Wait a minute. This is where the gadbad is. That's what I was thinking, that why it is not 35.4 divided by 52. Now what you will see now, this is 39, this is 52, this is 16. Either you can calculate and divide it, or you can simply calculate the ratio of this thing by actually dividing it all together, right? So that's why what you can do is 26.6 divided by 39, ratio 35.4 divided by 52, ratio 38.1 divided by 16. You can cancel this according to that also. So let's see what you're going to do here, right? this will be this is also coming out to be 0.68 only, right? And this will be, I think, 3 times, right? That is 2.3. This is 2.38, and if I multiply this 35.4 divided by 52, if I multiply this with 3, I am getting 2.04, which is not approximately same, I would say, right? This is coming out to be 0.68. 0.68. Here calculations are tough, that is absolutely right. Now, what is the simplest way of doing this is to calculate this in terms of the number, right? Once you have this, you will divide it. 0.68 divided by 0.68. 0.68 divided by 0.68. 2.38 divided by 0.68. This will be 1, this will be 1, and this will be something 3.3, I feel. It should be something 3.3. Wait a minute, 2.38, 3.5. It is coming out to be 3.5. Okay? 3.5 it is coming out to be. Then you have to be very, very careful in understanding this. 3.5 means it will be 7 by 2. Can I write it as 7 by 2? Right? It can be 7 by 2. Now, if you see this, if I multiply this by 2, this by 2, this by 2, it will come out to be in, this is K2, CR2, O7. Can you see this? This is coming out to be K2, CR2, O7. Right? And they have asked you just the empirical formula of this compound. Nobody is saying this is the molecular formula, though we know that this is the molecular formula, but we can't say this directly. K2Cr2O7 is the correct answer here. Right? Okay. In the exam, usually they don't ask these tough calculations, but in JEE they can ask, right? But usually it is not asked, but still because of JEE aspirants, you should be pro in this, right? Okay. Because this is actually a tough one, right? Otherwise, simple percentages are given to you that you can easily do. Okay. Now, let's do the next question, that is JEE Mains 2022. By this, you will get an idea what kind of question they ask you here, right? So, compound A contains hydrogen, carbon, nitrogen, percentage is given, right? Atomic mass of this, we already know. The molar mass of the compound is this. See, you have to, chalo, I'll just show you here what you have to do. See, hydrogen is 8.7, 74, and this is 17.3. So you have to make a table. Carbon is 74, nitrogen is 17.3, and hydrogen is 8.7. Carbon is nothing but, if you calculate if you know the molar mass of carbon, that is 12. Here it is 14. Here it is 1. So when you divide 74 by 12, this will be 17.3 by 14. This will be 8.7 by 1. Right? This is the percentage. This is the atomic mass. This is the moles. Okay. So when you calculate this, you will have 6.16, 1.23 and 8.7 here. Now divide it with the least number. Always when you have these kind of values, you always divide it with the least number here. Least number is 1.23 divided by 1.23, 1.23, 1. I also did the same here. Huh? Here also we did the same. After calculating, I divided it with the least number. Okay. So after dividing with the least number, what you will get is 517 here. That means carbon is 5, nitrogen is 1, hydrogen is 7. Right? Can you see what is the empirical formula here? Empirical formula is going to be empirical mass. This is the empirical formula, right? Empirical mass will be 12 into 5 plus 14 plus 7, which is for hydrogen. Okay. Now you can see 60, 74, right? Plus 7 that is 74 plus 7, that is 81. Yes, empirical weight will be 81, right? So that is going to be, empirical mass is going to be 81. Molecular mass is already given to us, molar mass is 162. So if I say N is equals to molar mass by empirical mass, that is 162 divided by 81, right? That is nothing but, this will always be a simple integer, right? So this is going to be 2. You put the value, that is C5N1H7 this is 2. So it will become C10N2H14. And that is your molecular formula, right? C10N2H14 is becoming your molecular formula here. Clear everyone, right? Simple questions these are, okay? Not to worry anything here, right? Next is, a gaseous compound is composed of this much by mass and this much by hydrogen. Let's see here, something different is given to you. Okay, here something different is given to you guys. Let's understand that. Let's understand what difference is given to you here. If you see this, they have given you gaseous compound that contains 80, this my mass of carbon, this my mass of hydrogen. Molecular formula you have to calculate, but they have not given you the molecular mass, right? But can you see, this is something they have given you. So, you know, variations they can give you, instead of giving you molar mass, molecular mass, they can give you a hint of calculating that, right? So I told you that in every lecture, you will see from one topic, I will not pick one kind of question. There will be different kind of questions that you will see, right? So now here, density is given to you, temperature is given to you, pressure is given to you, molar mass you have to calculate here, right? So directly we will apply this formula, that is D is equals to PM by RT, right? That is D. How you can remember this? PM is right. PM is right. Okay. D is equals to PM by RT. PM is right. Okay. So that is going to be M is equals to DRT by P. Now molar mass is equals to density is what? Now you have to also look for the units here. Density is 2.28 in gram per liter. Then you have R. R value what you will put here. See, because this is your pressure is in atmospheric, right? And they have given you density, volume, all these things they are talking about. So R you will take as 0.0821. That can also be written as 1 by 12. So I'll take it as 1 by 12. Temperature is 300 Kelvin. I'll also take it in Kelvin only. And pressure is 1. That's how you calculate the molar mass here, right? Okay. R value, how to decide? You will have to see that, okay, this is given in volume, so I'll have to put this R value. And this R value is nothing. See, I told you this in unit chapter also, unit and conversions, that 8.314 is nothing but 25 by 3. But this is only taken when we are talking about energies. But when we are talking about volume, pressure in atmosphere, right? Then we take 0.0821, that is nothing but 1 by 12, right? Okay, so in fraction, it makes the calculations easy, right? Now, you have the molar mass. After calculating molar mass will be this. That is 56.15 gram per mole. Now, see this. What you have, how to calculate the empirical formula, right? See, here they have given you this way, right? But we will calculate this in the form of table, right? So instead of table, because you don't have in the exam, you can't make table, how you will do this in the exam? This is carbon, this is hydrogen. Carbon is 85.7, molar mass is 12. Hydrogen is 14.3, molar mass is 1. Okay, directly you will do that, right? Now, after this, you have to take the simple whole number ratio. What you will do? This will be 85.7 divided by 12, right? So if I do one thing, see, simple whole number ratio you can calculate in one way also. That is, you multiply this by 12, this by 12, right? So once you multiply, the calculation will go really, really higher for you, right? Okay, either you can calculate the value of this thing, the value of this is nothing but 14.3. This is 85.7 divided by 12, right? So when you divide this also by 14 by 3 and this also by 14 by 3, right? Now you can easily get your answer here because this is going to be 1. This is going to be 1. Acha, wait a minute. That is 1 by 12. Maybe that will be the like smaller number. 85.7 will be smaller than 14 by 3. है ना? 85 divided by 12. That means 85 into 12 parts will be, it is a smaller value. So this must be divided here. So better is to calculate the value of this thing then to divide the smaller number with both the things, right? So when you calculate this value here, it will come out to be 7.14, right? So when you calculate this, it will come out to be 7.14, right? 7.14, this is 14.3. Now we can see this is the double. You divide it by 7.14. 7.14, this is nothing but 2, this is nothing but 1. So answer will be C2H1. Wait a minute. This will be 1. Okay. This will be 1, this will be 2. So answer will be CH2 is your empirical formula. Right. So empirical mass is going to be 12 plus 2, that is 14. Right. Molar mass we have calculated as, molar mass is nothing but we have calculated as 56.1, right? So this is your molar mass, this is your empirical mass, as you can see here, empirical mass. Calculate the value of N, that will be molar mass by empirical mass, that will come out to be approximately 4, right? So now what you have to think is that, okay, it is coming out to be approximately 4. Now empirical is CH2. This N value is this. So it will be C4H8 is the correct answer here. Right? Okay. So answer will be C is the correct answer. This is the latest question of JEE and it was a simple question only. Right? Next is, we have the empirical formula of a compound that is given to you. And in the question, trust me, they will not give you directly the empirical formula. I have already given you this just so that we don't repeat the same things, okay? So another kind of question that we can ask you is, its vapor density is 30 and now they are asking the molecular mass. Now what is the relation in vapor density and molar mass? That is very, very, very important for you. Let me just show you that. Molar mass is equals to 2 into vapor density. It's a very, very, very important formula. Right? Very important formula. Everything else is simple only. Right? See, everything else is quite simple. Right? So I'll just show you how. See, if you calculate the molar mass, that is 2 into vapor density, that is nothing but 60. Empirical formula is CH2O. So empirical mass is going to be 12 plus 2 plus 16. That is nothing but 14 plus 16, that is 30. Right? So now what you have to write, calculate the value of N here. N is going to be molecular mass divided by empirical mass. Molar mass or molecular mass is 60. This is divided by 30. This will be 2. Okay. So that means empirical formula, molecular formula will be equals to empirical formula and here it will be N. Empirical formula is CH2O. So CH2O and this will be N, that is 2. So it will be C2H4O O2, that is going to be the correct answer here. C2H4O2, that is B is the correct answer here. Okay, everybody, clear? Right? So that was here as simple question as that, right? Now moving towards our last question of today, that is your JEE Advanced question, right? Okay. Now this one is interesting, right? Can you see empirical formula is usually the ignored topic, but in JEE Advanced 2022, a question based on empirical formula was asked, right? This is a lengthy question, right? It's not like a simple question that we did before. So your brain will try to explore new places where you can actually apply this thing, right? Let's do this. Okay, let's do this, everybody. Let me know in the chat box if we shall start with this question. This is the last question of today, right? Last question of today. Ready, everyone? So here it is. To check principle of multiple proportion. Can you tell me what is principle? Principle of multiple proportion. A series of pure binary compound. This is P. This is P, M, Q, N. This was given. Their composition is tabulated below. The correct options are C. First thing is, some options are given to you. If you see the options, you will get an idea what exactly we are going to do there. They're saying if empirical formula of compound 3 is this, then the empirical formula of compound 2 is this. If empirical formula of compound 3 is this, atomic weight of compound P is this. Okay, so one by one we will solve this, right? Firstly, let us solve the first option. If the empirical formula of Q is P3Q4, then the empirical formula of the compound P, this is P3Q5. And can you see, this is a line, very, very important line that is mentioned here, that it follows law of multiple proportion, right? They are saying to check this, we have tabulated this thing here. That means it follows law of multiple proportion, right? So it's a very good mixture of law of multiple proportion and empirical formula. Two most ignored topics from your chapter, right? Okay, that students find that who will ask question from this topic, right? So that's how they ask the question, okay? As I told you before also, law of chemical combination, they will not ask you directly. They will just put that thing in some question. It's direct questions are not asked in law of chemical combination or empirical formula also. Empirical formula also, they will try to complicate the question by mixing it with maybe stoichiometry, maybe limiting reagent. Some other topic will be mixed if they want to have a JEE Advanced question or even JEE Main question out of it, right? So now if you see this, to check the principle of multiple proportion, that means one atom will be, or one element will be fixed. Okay. So I have to fix one atom. That means the weight of one atom I have to fix. So this is 50. If I make this also 50 and I make this also 50, then I have to calculate what is P, what is P. First you have to do that, only then you will be able to solve the next questions. Okay. So when I want to make this, then what I will do? This is the original percentage. Now see this thing. We can say in 55.6 of Q, you have 44.4% of P. Then 1 of Q will have 44.4 divided by 55.6. Then what about 50 of Q? Because we want to calculate, we want to make this also 50, this also 50. For that, we have to apply a unitary method, right? So we are saying that if the percentage of Q is 55.6, then the percentage of P is 44.4, right? For 1, it will be, I'll just write 1 only, otherwise you will get confused. For 50 Q, it will be, for 50 percentage of Q, it will be 44.4 divided by 55.6 multiplied by 50, right? And when you will solve this, answer will come out to be 40. That means if Q is 50 here in the second compound, then P will be 40, right? Okay. Now, let's understand one more thing. If I put this also as 50, so what I'll do here? what I'll do here? Again, I'll apply unitary method. That is 60 of Q has 40 of P. 1 of Q has 40 by 60 of P. Then 50 of Q I want to know, that will have 40 by 60 into 50 of P. So answer is going to be, that is 33.3, right? So that's why we have this new table here. So instead of writing this, we are having this new table here. Let me know if that is clear to all of you or not. Right, everyone? Let me know if that is clear to all of you or not. What we are saying is that here you had which thing? I am fixing the Q. Q is fixed. Q is fixed. Because whenever I ask about that multiple proportion, in that we have to fix one thing. Okay? Now I have fixed one thing. Now I'll again go to the statement and I'll see if empirical formula of the compound 3 is P3Q4. See, if I am saying that this is compound, A statement is empirical formula of this is P3Q4. Now see this very carefully. P3Q4. And of compound 2 is P3Q5. So law of multiple proportion is applied here, right? So to understand this, to verify this statement, you have to go through two things. One is, by applying law of multiple proportion, this is, see, compound number 2 is P3Q5. I also want to make this as 5 so that I can see what is the ratio of masses of P, right? So here, what I'll do, this is P3Q4, P3Q4. If I make it, if I multiply this by, because I want to make it 5, so I'll divide it by 4 and I'll multiply it by 5. This will be, I'll divide it by 4, multiply it by 5. This will become P15 by 3 and Q5. Okay. Now, what exactly, first just go very patiently, go through the full question, okay? What I am doing here. This is nothing but I am making this P3Q5 as nothing but I want to make this also Q5. See, why ma'am, you are not making this as P3Q4? It's totally my wish, right? You can also make this as you can also fix here Q as 4, right? It's totally your choice. You just need to see by fixing a Q, what is the ratio of P that you are having. By fixing Q, you can say by fixing Q, ratio of P is nothing but here it is 15 by 3 and this is 3. Right? Okay. So that is nothing but, wait a minute, that is 15 by 4, na? My bad. This will be 15 by 4. 15 by 4 and this is 5. So here also you write 15 by 4 only, right? Ratio, this is 3. This is 15 by 4, this is 3. So I'll take the ratio, this will be 15, 4, 3, 12, right? So that will be nothing, 3, 5, 15, 3, 4, 12. That is 5 ratio 4. That is 5 ratio 4. That is from the statement we have. Now the data that we have is this thing. Now here when you fix the Q for compound 2 and 3, I fix 2. I fix Q. Then what is the ratio of P of compound 2 and P of compound 3? P of compound 2 and P of compound 3. Here also I am writing P of compound 3 by 2. Hai na? So here I'll write P of compound 3 by P of compound 2. The ratio should be same, okay? If the ratio is same, that means this statement is verified. So this is P of 3 is nothing but 33.33. This is nothing but 40. 15 by 4. 5 by 4, na? That is not going to be same. It is not at all coming out to be same. It is coming out to be 5 by 6. You can see this also. This is nowhere. This is a smaller value by bigger. This is bigger value by smaller. This is not at all coming out to be same. Okay? So that's where this statement is not verified. A will be the incorrect option. I'll again explain this. See, this is the experimental data. This is the experimental data that was given to you. This data is definitely correct. So all the statements we will verify with this data, right? So the first statement is, if empirical formula of compound 3 is P3Q4, then the empirical formula of compound 2 is P3Q5, right? So for that, to verify this statement, what we did, we applied law of multiple proportions here, because that is given in the first statement that it is applicable, law of multiple proportion is applicable. So from the data also, I fix the value of Q. Here also, when I fix the value of Q, this is the table that you have. So in the table, when I fix the value of Q, the ratio of P3 and P2 is going to be 5 by 6. But in the formula that is given in the statement, that compound this has P3Q4, this has P3Q5, then the ratio is coming out to be 5 by 4. That is not the same ratio. That means this statement is not correct because it is not aligned with the data that is given to you in the question. Okay. Now, next is, second is, wait a minute, let me see what is given here. So first statement is definitely incorrect. If empirical formula of compound 3 is P3Q2, atomic weight of P is 20, atomic weight of Q is 45. Here you will apply empirical formula as well, right? So how you will apply empirical formula of the compound is P3. See, we have to put these values. P is 20, atomic weight is 45. Okay, so let's put this here. Let's put this here where it is. See, this is B. How you will solve this? This is P, this is Q, right? Now they are saying that this is in compound which? This is in compound 3, right? P is 20, Q is 45. P is 20, compound 3. Now, whenever you are using this thing, whenever you are using empirical formula, you are calculating for the method of empirical formula by making table, you will not use these values. You will use these values because I told you initially that the total percentage has to be 100. This table I have made to apply law of multiple proportion. This table is actually the original data. So here I will say that P is 40. So what I'll do, this will be atomic, given mass is 40. Here it is 60. Is it? 40 and 60. Atomic number they have given to be 20 and here they have given to be 45 in the option B. If you can see in the option B, they have given you this thing, right? Atomic weight is 20, atomic weight is 45. Now, if it is coming out to be P3Q2, then the option will be correct. If you see this, while calculating, right, this will be 2 and this will be, this will be 5 by 4, right? 4 by 3. Okay, 15, 3 and 4. उसमें it will go. Okay, so it is going to be, right, 15, 3, 15, 4. So now if you see, this is 2, this is 4, 3. If I multiply this by 3, if I multiply this by 3, this is going to be what? This is 6 and this is going to be 4. You take this ratio, this will be 2, this will be 3. So can I say this will be P3Q2? And this was the same thing that was given in the question also. So that means B is definitely the correct statement here. When you put the atomic weights as 20 and 45, you will get the empirical formula of compound 3 as P3Q2. That is the correct statement. Now the third statement is, this is the correct statement. The empirical formula of the compound is 2 is PQ. Then the empirical formula of compound 1 is P5Q4. Again, you have to apply law of multiple proportion here, because when the comparison is given, you have to apply. You can't solve it because no atomic mass is there. So how you will calculate the, here in the option B, they have given you atomic mass. So that's why you were able to calculate empirical formula. But here what you will do, you will verify from the data that if this is compound 2 is PQ, if I want to make Q constant, so this will become P4Q4. That means from this data, the ratio of P is ratio of P in compound 2 in the ratio of P in compound 1. That is going to be, in compound 2, P is 4. In compound 1, P is 5. So that means the ratio of compound P in compound 2 and P in compound 1 has to be 4:5 from the data also. Only then the statement will be correct, right? So if you see the data here, this is the data, right? When you fix Q here, the ratio of P2 by P1 is going to be, P2 is 40, this is 50, that is 4/5. That is the same thing as this, 4/5. That means C is also the correct statement here. Now, till now, we have two correct statements, right? Fourth statement will be, if atomic weight of P and Q are 70, and now same thing that we did in B, respectively, then the empirical formula of compound 1 is P2, right? So, atomic weight of P, atomic weight of Q, right? Atomic weight is, here it is 70, and Q is 35. Okay, if you see this here, whenever you are calculating the, again I am saying, whenever you are calculating the empirical formula by this table composition of atomic weight, then simple whole number ratio, then you will use this data. This data is to law, whenever you are using law of multiple proportion. This table is to verify with the help of law of multiple proportion. This table is for calculation of empirical formula by method, by proper method when you are calculating, right? So here can you see for compound, empirical formula of compound 1 is, this should be P2Q, okay? This should be P2Q. They are saying empirical formula should be P2Q, right? So now if you see this here, compound 2 is 44.4 and this is 55.6. It will be 44.4. It will be 55.6. Then you just have to solve this value. And let's see if you get the comparison. This not. Wait a minute. That means, chalo, let's solve this. Chalo, you solve this. 44.4 divided by 70. That is 0.63, okay? And this is 55.6 divided by 35, that is 1.58, right? Can you see this is half of this, so it will be 1 and this will be 2, because when you divide it by 0.63 divided by 0.63, that is 1. This is 1.58 divided by 0.63. That is nothing but 2. So answer is coming out to be PQ2. But here they have given it should be P2Q. So this should not be the correct answer. That means this statement is incorrect here. Right? I know that was a lengthy question, but these kind of questions is what they ask in JEE Advanced. Right? And for this, definitely you have to be really good in calculations, because in JEE Advanced, good calculations they will ask you, right? And students, I'll just again explain this. Law of multiple proportion and empirical formula method, two things we are applying. Whenever we are comparing two empirical formulas, we are applying law of multiple proportion, that from the option we are calculating the ratio, we are fixing Q in the data. Then we are calculating the ratio of P. We are fixing Q in the option. If you see this in the option also, we are fixing Q. This is Q4. This also be Q4. then we are calculating the ratio. If that is same, then it is verified. If that is not same, it is not verified. In one kind of option where atomic weights are given to you, you are solving it with the previous method only by putting moles is equals to percentage by atomic mass, and then you calculate the empirical formula. By this, you will verify these 4 statements. Okay, students, clear? Now let us see what is the homework. So homework is, which of the following cannot be empirical formula? That is the first question, right? Then take the screenshot of this. You have to tell me which of the following cannot be the empirical formula. I'll wait for your answers in the comment section, okay? Then this is, if molecular formula is equal to n into empirical formula, then 1 by n is what? Students, very good. Then what is the value of 1 by n? Molecular formula by molar mass, empirical by molecular mass, empirical formula by molecular mass by empirical formula. This is the second question. First, and this is second, and I want to see your comments of doing homework in the comment section. And students, this is a very, very important news for all the students who want to be in a really, really good batch, where live classes are provided, mock tests are being taken after every 15 days, test series are provided, modules are provided to you, and for your revision, these kind of quick cards are also provided to you for your revision, right? So all these things are, and even in the class as well, if you watch the replay version, in that also you can ask your doubts. In class, you can ask your doubts. In the replay version also, you can ask your doubts. So all these things are provided to you in the Sigma batch, that is at 4999, right? So students, you can check out the link in the description box and get yourself enrolled into this batch, because I am also teaching in this batch. All your favorite teachers are there in this batch. So I would love to see you in this batch, because interesting things are going on, quizzes, leaderboards, all these things are going on. No spamming, nothing is there, right? Because the batch is like a family, right? In which definitely if the user, right? Because that is our own platform. If the user is spamming, we just block the user. So that's why students are very disciplined, very sincere. You will get to know about the competition that you have on daily leaderboards. You will see that where actually you lie and how much you need to improve. And after every 15 days, the amount of syllabus that we have completed, we also take the mock test, right? And all these things makes you pro for your JEE preparation, right? So that's why get yourself enrolled to this batch. And this is our JEE English channel, which you can subscribe, because here all the live updates of JEE and our sessions that we are going to conduct, everything will be there on this channel that will be updated, right? So now I would love to see your homework in the comment section, everybody. And don't forget to like this video, share this video with a friend also, right? Okay. Chalo. Now I'll leave now. Take care. Bye bye. Tata. See you all in the next class. And next class is going to be about POAC law of one law, that is of equivalent mass, right? So we are going to talk about equivalent mass. POAC, we are going to talk about percentage composition. So next particular lecture is going to be very, very important for you. It is going to be a little bit lengthy, right? But it is going to be very important for JEE Advanced kind of questions. Okay? Yes. Okay then students, bye-bye. Take care. See you all in the next class. Bye-bye.